Hey everyone, and welcome to episode 3 of my Help with Maths homework series. Right, people put heaps of questions in my free maths help group on Facebook. Then I put to a vote which questions do you want me to answer, and I answer them here. So normally I do 3 a week, but today I thought I'll do 4. So yesterday I did on the video would have been on linear relationships and projectile motion. Today is on trig and inverse trig, right? I thought those would go well together, so let's kick off. Okay, so the first question is find the 5 remaining trig function values for theta given that cos theta equals negative 2 root 3 on 5 and cosec theta is greater than 0. Okay. Alright, so when we're dealing with this is part of the topic, find the value of a trig ratio given another. So first off, we need to know what quadrant we're in. Okay. So cos is negative. What quadrants is cos negative in? Well, if you do your all stations to central acronym, is what we learn here in Australia. All stations to central. Cos is negative in quadrant 2 and 3. Okay. Now cosec theta. What's cosec? Well, cosec is 1 over sine theta. So where is sine theta? Positive. If we look here, it's just 1 and 2. So then we look, where's the overlap? Well, the overlap is 2. So we're in quadrant 2. So that tells us if our answers are going to be positive or negative. Now to find the values, we go to here and we draw a right angled triangle for theta. So we ignore the minus because the minus just tells us what quadrant we're dealing with. So cos theta is adjacent over hypotenuse. So this is 2 root 3, and this is 5. Okay, so now we need to find the opposite side. So we use Pythagoras, which would be square root 5 squared, so 25 minus 2 root 3 squared, which is 12. Right, 2 squared 4, root 3 squared is 3. So that turns into minus root 13, or just root 13. So now we can just list down the other ratios. So sine theta. So sine would be root 13 over 5, and we're in quadrant 2, so sine's positive. Then we can write down tan theta. Opposite over adjacent, root 13 over 2 root 3. That's shocking. 3. Now we're in quadrant 2. Tan is negative, so we're going to chuck the negative there. So now we need the values of the other 3, the reciprocal ratios. So the first one would be cosec theta, which is 1 over sine. We use the third letter to remember that, which I'll do a future video on. So that means we flip this. So it'll just be 5 over root 13. Then sec theta is 1 over cos theta. So we're just going to flip that. 5 over 2 root 3, and we'll leave the minus at the front. And lastly, cot theta. We're just going to flip tan theta, right? Because cot is 1 over tan. So 2 root 3 over root 13 with a minus. So whoever posted this question, I hope this helps. And for anyone who struggles with these type of questions, I hope this helps. Let's get into the next question. Okay, the next question on inverse trig. So find the inverse function for f of x equals cos x plus pi on 3 if x is between 8 pi on 3 and 11 pi on 3. So to find the inverse function for something, we want to swap x and y. So it'll look like that, and then we just make y the subject. So to get rid of the cos, we cos inverse both sides. And then we get y equals cos inverse x minus pi on 3. Now there's a problem here, because if we look here, this is the domain for that and this is the range. But for the inverse, it swaps. So now this is the domain and this is the range. So what you see happens here is if you sub 8 pi on 3 here, you get negative 1. You sub 11 pi on 3 in here, you get 1. So these values should match. So that means the same happens here with the inverse. So if I sub negative 1 here, what's cos inverse of negative 1? That's pi. Okay, but if I put, that's a minus just if you can't see. If I put pi here, pi minus pi on 3 is 2 pi on 3. That's not 8 pi on 3. And we're going to get the same problem here. So the trick here is the angle is too small, right? Because this represents an angle. So the trick here is sine and cos repeat every 360 degrees or 2 pi. So we actually have to add 2 pi here to account for this higher domain, right? Because then if we add the 2 pi, this turns into plus 5 pi on 3. Okay, so then you sub negative 1 in, cos inverse negative 1 is pi, pi plus 5 pi on 3 is 8 pi on 3. Now it matches. Okay, so you can see the trick with these inverses is they have to make sure you match the values, right? If these values match, then they should match it for the inverse. So if they don't for sine and cos, you have to either add or subtract 2 pi, depending if you're lower or higher, like we did here. Because we were lower here, because of the minus pi on 3 made us too low, that means I had to add 2 pi. If this minus pi was a plus pi on 3 and it was too high, then I would subtract. Right, so these are a little tricky, so I hope I might do a future tutorial on that properly. But whoever posted this question, I hope this helps and that everyone enjoys this homework series, episode 3. Okay, so make sure to comment below and tell me if you enjoy this maths homework help, and to check the link in the description to join my free maths help group so you have the chance to get your questions featured here. Otherwise, I'll see you guys tomorrow.